Hello students, welcome back to my channel. So today we will be solving this problem LeetCode number 283 move zeros. Okay, so given an integer array nums, we have to move all the zeros to the end of it while maintaining the relative order of the non-zero elements like this. 0 and 0, these two zeros are there. So these two zeros will move to the end while maintaining the relative order of the non-zero elements like 1, 3, 12 will follow the ordering as it is and zeros to the end. But there is one suggestion, like we must do this in place without making a copy of the array. Okay, so we have to do this in place in the nums without using any other extra array. Okay, so I will be doing this also, but before that there is a brute force approach which we will be making an extra copy of the array. Okay, and then we'll have the non-zero elements in the extra copy of the array, and after filling then what we'll do is we'll move back the elements from that extra copy to the nums and fill the remaining zeros. So that is a brute force approach which will take big O of n extra space, and time complexity will be big O of n only, but space will be big O of n. So let me explain like how what we will be doing on one note for this brute force approach. First, let me copy the test case. Okay. So input is what? 0, 1, 0, 3, 12. Okay. So now we'll make an extra copy of array. Okay. An extra copy of the array we'll make. This will be, and whatever the we'll iterate on this nums. Keep on iterating on this nums. Whenever we are getting the non-zero elements, we'll put in the extra array. Like 1 we'll be putting, then 3 will be putting, and 12 we will be putting. Then what we will be do is, whatever the size of this array is, whatever the size of this extra array is, how many elements are there, we'll be putting back to nums. So 1, 3, 12, and when the size is completed, we will be doing 0 and 0, putting 0 and 0, remaining whatever it is. So now we have done this with the help of an extra array and we have completed our answer. Then we return from the function. So this is going to take an extra space of big O of n. This one, big O of n. Why big O of n? Because let's say the elements, all of them are the non-zero elements. Right now, it's looking like only 3 elements are there. But let's say here 8 was there, 9 was there, then all the elements would have come here. So in the worst case, it is big O of n space. So I'm not going to implement this brute force one. What we will be doing is we will be using an optimal solution which will be having big O of 1 extra space. I have told you, like in comment section you can mention like if you want me to implement the brute force also, I will implement the brute force also. Okay. So now what we'll doing is we will be implementing uh, optimal solution we'll be implementing. Okay. This is 0, 1, 0. What it is? 0, 1, 0, 3, 12. So it is 0, 1, 0, 3, 12. So here what we'll be having is we'll having 2 pointers. One pointer will be I. I will be pointing to -1 initially, and J will be pointing to 0 initially. I is the pointer where we will be putting the non-zero elements, and J will be used to traverse to the array elements. Okay, in the same array. We will not be using the extra array to solve this optimal solution. Okay. So initially J is 0. So nums of I is not equals to 0. It is false. Then we'll increase the J. J will be 1. Nums of I is not equals to 0 is true. Nums of J, sorry, not I. Nums of J not equals to 0 is true. So what we will do is, initially I was at this index -1, hypothetical index -1. -1 does not usually exist. This is a hypothetical index. So whenever the element is there, like non-zero element is there at jth place, what we'll do is we'll increment the I, like I will go to the 0th index and assign the non-zeroth element to the that place, ith place. So 1 will come here. Then j will move to this place. 0 is there, so this will not increase I and assign. Then 3 will be there. So here we have to increase the I and assign. So 3 will be coming here. Then j will be coming here 12. Here also it is non-zero. Then we will incrementing the I and assigning here. So 1, 3, 12. Then when this is this assigning of non-zero element is done, we'll increase we'll increase one index of I by 1 and fill till the length of the array. How many are remaining are there? So in this way, we have solved this question in the constant extra space without using any other array. So this is a 2-pointer pattern question. So there are 2 pointers and we have solved it. Now let us implement this problem in LeetCode. So according to dry run, what we are having is we are having I equals to -1, comma, and n is the length of the array, and then for int j equals to 0, this is the j for which we are traversing on the array. And if, as discussed in the dry run, if nums of j is not equal to 0, what we'll do is we'll do nums of first increment the I, then assign it to I, okay, and j will be incremented anyways. Then when this loop is done, we have seen like we have to increment this I by 1 and I should be less than n and I plus plus, okay. We'll be having nums of I equals to 0. And then automatically this call will done. Now let's check whether this is working for the sample test cases or not. This is the optimal solution and it's working. Now let me submit it whether it works or not. Finally it works or not. Okay. Yeah, so this is working fine. This is getting accepted. So that's it for the problem. Now if you are, I want to communicate with you people, like if you want to say something, you can comment on the videos. And if you like my videos, please do subscribe to my channel. Yeah. So that's it for the problem.